You know that feeling, right? When you have to get your medical records moved from one doctor to another. It's just this chaos of faxes and weird PDFs and data that refuses to talk to each other. It's a mess. But what if I told you that the blueprint for fixing all of this wasn't dreamed up in some Silicon Valley startup last year, but was actually laid out in detail in a research paper from 1988? Yeah, you heard that right. It's pretty wild. Let's get into it.
All right, so here's our game plan. We're going to start by jumping back in time to the paper-based nightmare to really understand the problem. Then we'll look at the incredible vision these researchers had for a digital future. After that, we'll uncover the secret ingredient, the real genius move that made it all work. And finally, we'll trace how this idea went from a university lab to a huge player in the industry, leaving a legacy that we're still building on right now.
Okay, so first, you have to picture it. Before everything was digital, every single piece of your medical story, every doctor's scrawled note, every lab result was on a physical piece of paper, stuck in a fat folder, and locked away in a giant filing cabinet. And honestly, it was a massive, massive problem.
Now, take a look at this quote. It's from the very paper we're talking about. But the key thing to notice is the date, 1988. I mean, think about that. Even back then, they were pointing out this desperate need for records that were, and I quote, legible, well-organized, readily available. Does that sound familiar? It should, because we are still fighting this exact same battle today.
And the stakes were, and still are, incredibly high. This isn't just some minor inconvenience. As the paper points out, bad records lead to worse healthcare. It means doctors have to do the same test twice because they can't find the first result. It's a huge dead end for researchers who need that data. It's just frustration and wasted time for everyone involved. So fixing this was never just about being tidy. It was about the actual quality of care.
So, into this paper-based chaos, a team at the Chicago Medical School dropped this truly forward-thinking concept. They called it the portable patient file.
And let's be clear, this wasn't just about scanning pages and making digital copies. No, their vision was for an intelligent system. It wasn't meant to be a dumb digital filing cabinet. The idea was for it to actively organize the data so it could help with diagnoses, track how a patient was doing over time, and supercharge research. For 1988, that was an unbelievably ambitious goal.
Now, great ideas rarely appear out of thin air, right? And this was no exception. The authors were building on earlier work, like Dr. Lawrence Weed's idea for a problem-oriented medical record, way back in the late 60s. So this 1988 paper, highlighted here, was really the next big leap forward, taking that organized way of thinking and figuring out how to make it automated, intelligent, and portable.
Okay, but how on earth do you get data from a bunch of different doctors, labs, and hospitals to be understood by one computer system? This is the million-dollar question. And the researchers came up with an answer that was so simple and so brilliant, you can really think of it as a kind of medical Rosetta Stone.
Here's the core challenge they had to crack. A specialist uses one term, the lab uses an abbreviation, your family doctor writes something else in their notes. They're all talking about the same thing, but they're using different languages. How does a computer know that WBC and white blood count are the exact same concept?
Their solution was something they called the feature dictionary. And it's just a beautiful idea. Instead of trying to teach a computer an infinite list of synonyms, you create one central dictionary. And every single medical concept, every feature, gets its own unique number. It doesn't matter what a person calls it. The computer only cares about that one unique code.
And this slide right here shows you exactly how that magic works. So if you look at the table, one doctor might type in the full white blood count, while another just uses the abbreviation WBC. The feature dictionary is the translator in the middle. It maps both of those terms to the exact same code, in this case, code 1012. And just like that, the data is standardized, it's clean, it's usable, you've created a single source of truth.
And this was way more than just a simple list of numbers. No, each entry in this dictionary was incredibly rich with detail. It had the unique number, sure, but also the proper long-form name, all the common abbreviations, what type of data it was, like a yes-no answer or numeric value, and even what the normal range for a lab result should be. This is the kind of deep context that makes raw data actually useful for a doctor.
So, you have this amazing idea sitting in a research paper. But did it just stay there, collecting dust in a university library? Oh, you bet it didn't. And this is where the story gets really, really compelling.
So we start here. It's 1988, and this is an academic proposal. It was the heart of a system they were building called MADIS,
which stood for Medical Assistance System. It was a brilliant university project, a proof of concept.
But then this happened. The concept of the feature dictionary was just too powerful to stay in the lab. It was spun out, and it became the foundational technology for a commercial company you might have heard of, Intelligent Medical Objects, or IMO. Today, their terminology is used in thousands of hospitals to make clinical data actually make sense. This idea didn't just get published, it went out and shaped an entire industry.
So let's bring it all home. Why are we talking about a 30-plus-year-old idea today? What is its lasting impact? Well, it's pretty much everything.
The authors themselves spelled out their grand vision right there in the paper. Listen to this quote. The goal was to enable any two systems to establish a link for communication in a standard and interpretable form. I mean, come on, that is the very definition of what we call interoperability today. It's the entire goal of modern standards like FHIR, which stands for Fast Healthcare Interoperability Resources. They were literally drawing the blueprint for it back in 1988.
And that really brings us to the final thought here. That core idea from the 1988 feature dictionary. The idea of mapping all the messy human language to a single, structured, coded concept is the exact same principle that powers modern data standards like FHIR. It really makes you wonder, doesn't it? As we're building the future of healthcare data, how many of our new ideas are truly new, and how many are us just getting better at putting into practice the brilliant ideas that people had decades ago?